So today we're going to be talking about a dimensional analysis problem in your general chemistry course that has a couple of confusing terminology terms in here. So let's address those. So the first thing that we can talk about is sort of the molecules that we're using. This AgNO3 and MgCl2, not ones you typically see, but may show up in a problem like this, and I don't want that to scare you. But let's look at this problem. In a 50 milliliter solution of 0.25 molarity AgNO3 with excess MgCl2, what is the mass of the precipitate? So first, what's this question asking? Obviously, it's what is the mass of the precipitate? But what is the precipitate? That's the stuff in the solution that does not mix with the rest of it and sort of remains as a solid. So you ask yourself, what molecule here, MgCl2 or AgNO3, is going to be the precipitate? We know that it's the excess stuff, and so it's going to be MgCl2. So that is the molecule that we're looking for in this dimensional analysis. Now the other thing is to look at the big M, right? That's moles over liters. And we also have liters. That's kind of what's in our toolbox, right? We're given 0.25 molarity of AgNO3 and we're given 50 milliliters. So let's start with the molarity. So we have 0.25 moles over 1 liter. We also are given that we have 50 milliliters, so we have to convert that to liters. So in 1 liter, we have 1,000 milliliters. And since we were given 50 milliliters, now we've converted it properly. We assume a 1-to-1 mole ratio between AgNO3 and MgCl2. So because this first one is really, we want to add, make sure this is AgNO3, so that way it cancels out later on. Now what we do from here is we need to go to our periodic table and find the mass of 1 mole of MgCl2. And that's going to be used by the atomic mass. And we can find the weight of sort of 1 mole of each of the elements in this molecule. So magnesium is around 24 and chlorine is around 35.5. So when we add that up, we're going to end up with 95 grams per 1 mole of MgCl2. Now we can see we have our units canceling out now to leave us with what we want. We want mass, so we're looking for grams. So mass of the precipitate, that's what we end up with. Mass of precipitate is going to be in grams. And so that's the unit we're looking for. The rest of the stuff cancels out. We have 1 liter, moles AgNO3, moles AgNO3, milliliter, moles of MgCl2, moles of MgCl2. And when we calculate this out, we end up with about 1.19 grams MgCl2. And that's going to be your precipitate.